We start a question answer session on network, and this is lecture number 1. The first question that we address is the following. Show star connection of resistances R1, R2, R3. The answer. 3 resistances are given and let us construct a combination of them by connecting all the 3 at a point while keeping the other point free or open. This is it. Call this resistance R1, this is R2, and this one let us call R3. The combination, as we have built it, looks like a star. Hence this network is referred to as star network. Let us redraw the network as follows. Keeping the connections identical, only the presentation or the drawing or the layout will be different. These are the 3 resistances connected at a point. The other point is free, as in the first left side diagram. Resistances are R1, R2, R3. So essential connections are identical, but the look has changed. The network now looks like the letter T. So this is called T network. It is always useful and safe to label the junctions as well as the free ends. This will ensure that we do not make any mistake in circuit analysis. So let us label the important points. This junction or meeting point of the 3 resistances R1, R2, R3 be denoted by O, and the free ends, let us call them A, B, C. The same here. Let us check. Resistance between OA is R1, resistance between OB is R2, while resistance between OC is R3. We can redraw the resistances in yet another way, and it is as follows. The network now looks like the letter Y. So this is called a Y network. We have thus described the star network, also called the T network or Y network. Let us consider the next question. Show delta connection of resistances R1, R2, R3. The answer. Let us combine the 3 resistances R1, R2, R3, and the terminal points are A, B, C. So they are connected one after the other to form a loop. This network looks like the symbol delta, and the network is referred to as delta network. We redraw the network, keeping the essential connections intact. Let us just reshape the network, put it or draw it in this form. Write the resistances. Did we write the resistances correctly? Check. Between A and B we have R3. Between A and C we have R1. And between B and C we have R2. Look at the CC line or a simple where. All points on it are equivalent. Denote all the points by C. How does the network drawn in this manner look like? Looks like the symbol pi. So this network is referred to as pi network. We thus have finished discussing delta network, that is also called the pi network. Next question. Write down the relation to convert a star network to equivalent delta network. The answer. Let us draw the star network comprising of 3 resistances. Call the resistances R1, R2, R3. The terminal points are A, B, C, and this is point O at which the 3 resistors coincide. This is the star network. We redraw the network. Join the points A and B, B and C, A and C. The resistance between A and B is say R3. Resistance between B and C is say R1. Resistance between A and C is say R2. What is the formula that connects the resistances capital R1, R2 and R3 of the given star network and the resistances small r1, r2 and r3 of the imagined delta network? In this problem, we will express the resistance values of the delta network in terms of the resistances of the star network. And the relations are, let us write it explicitly. Small r1 equal to sum of the pairwise product of star network resistances, that is sum of the pairwise product of capital R's divided by capital R1. Look, capital R1 lies opposite to small r1. Small r2 equal to sum of pairwise product of star network resistances, that is pairwise product of the capital R's divided by capital R2. It lies opposite to small r2. Small r3 is sum of pairwise products of star network resistances, that is pairwise product of the capital R's divided by capital R3, which lies opposite to small r3. Any delta resistance is equal to sum of pairwise products of star resistances divided by that star resistance which lies opposite to it. This can be proved. Let us draw the delta network we have derived. Between points A and B, the resistance is small r3, and between points A and C, the resistance is small r2, while between points B and C, resistance is r1. This is the equivalent delta network, equivalent to the star network. Let us underscore the formula once more. This is the star network, and let us consider the imagined delta network. In star to delta transformation, the formula is sum of pairwise products divided by opposite resistance is equal to resistance of delta. To be precise, let this be small r, a delta network resistance, and let this be capital R, the resistance of star network that lies opposite to small r. Then small r is equal to summation over pairwise products divided by capital R. Next question. Convert the star network, and here it is. The resistances are 1 ohm, 2 ohm, 3 ohm. The terminal points are A, B, C, and we have to convert it to an equivalent delta network. The answer. Let us redraw the given star network. Join the points C and A and B, C and B. Resistance between A and B is, say, R1. Resistance between C and B is, say, R2. Resistance between C and A is, say, R3. To find the resistances of the imagined delta network, that is R1, R2 and R3, we have to use the formula of conversion from star to delta. So we have R1 equal to 1 ohm into 2 ohm plus 2 ohm into 3 ohm plus 3 ohm into 1 ohm. This is the sum of the pairwise products divided by 1 ohm, which is the resistance between C and O point, that is opposite to resistance R1. Calculation gives 11 ohm. What about R2? R2 is the sum of pairwise products divided by 2 ohm. The resistance in OA branch, that is opposite to R2. This gives 11 by 2 ohm. R3 is the sum of pairwise products divided by 3 ohm, the resistance in OB branch, that is opposite to R3. It is 11 by 3 ohm. Let us draw the delta network now. This is it. The resistances are. This is the equivalent delta network. Next question. Write down the relation to convert a delta network to a star network. The answer. Let us draw a delta network. The resistances are R1, R2, R3, and the joining points are point A, B and C. This is the delta network. Let us redraw it. Now build the star network within the delta. Denote this point as O point. Let the resistance in the OC branch be R1, resistance in the OB branch is R2 and the resistance in OA branch is R3. We want to write down the formula for conversion of delta network to an equivalent star network. Small r1 of the imagined star network is given by the product of the resistances capital R2 and capital R3 of delta network that are attached to small r1 divided by the sum of delta network resistances. Similarly, small r2 of the imagined star network is given by the product of the resistances capital R1 and capital R3 of delta network that are attached to small r2 divided by the sum of delta network resistances. And small r3 of the imagined star network is given by the product of the resistances capital R1 and capital R2 of delta network that are attached to small r3 divided by the sum of delta network resistances. We can prove these relations easily. Let us draw the star network that we have derived, and these are the resistances. This is the equivalent star network equivalent to the delta network. Let us mention the conversion rule once more. This is the delta network and this is the imagined star network. We are discussing delta to star transformation. The product of attached resistances of the delta network divided by the sum of all resistances of delta network will be a resistance of star network. To be specific, if this resistance of star network be small r and the attached resistances of the delta network be capital R1 and capital R2, then small r of delta network can be expressed as product of capital R1 into capital R2 by sum of delta resistances. Next question. Convert the delta network, and this is the one we are referring to. Resistances are 11 by 3 ohm here, 11 by 2 ohm and 11 ohm. The terminal points are A, B and C. Our task is to convert this to equivalent star network. The answer. Let us draw the given delta network here in the answer portion, and let us draw it once more for making the conversion. Now build or imagine the star network within the given delta around the point O and show the resistances R1, R2 and R3. Apply the conversion formula. R1 is, look at R1, it is attached to the delta resistances 11 by 3 ohm and 11 by 2 ohm. So we take their product and divide by the sum of all delta resistances. Calculation gives us 1 ohm. Now what is R2? Look at R2. It is attached to the delta resistances 11 by 2 ohm and 11 ohm. So we take their product and divide by the sum of all delta resistances. Calculation gives us 3 ohm. What is R3? Look at R3. It is attached to the delta resistances 11 by 3 ohm and 11 ohm. So we take their product and divide by the sum of all delta resistances. Calculation gives us 2 ohm. We are thus in a position to draw the star network that we have built. Here it is. Put the resistances we have calculated. So this was the given delta network and this is the equivalent star network that we have created. Question. Consider the network. Let us show it. 5 resistances joined in this fashion, and the resistances are 1 ohm, 2 ohm, 3 ohm, 4 ohm, and the fifth one 5 ohm. In this problem, we shall be interested with the terminal points A and B. The question is, obtain equivalent resistance between A and B. The answer. Let us redraw the circuit. Let us focus attention to this delta BCD, and we shall convert it to star network. Hope it simplifies the problem, as we would apply the delta to star transformation to BCD portion of network, which is delta in shape. We have to draw everything once again, and we do it. Now build the star network inside this delta, and let us call this resistance R1. Let this one be R2 and this one is R3. Apply the formula. So R1 of the imagined star network is the product of the attached resistances. What are they? Look at point C. R1 is attached to the resistances 3 ohm and 4 ohm. So the numerator is product of 3 ohm and 4 ohm. The denominator is the sum of all the delta resistances. So it is 3 ohm plus 4 ohm plus 5 ohm. Calculate to get 1 ohm. Now focus on point B of network. R2 of star network is connected to which resistances of the delta network? They are 4 ohm and 5 ohm. So R2 will be the product 4 ohm into 5 ohm divided by the sum. The answer is 5 by 3 ohm. Similarly, R3 of proposed star network is attached at point D to the star network resistances 3 ohm and 5 ohm. So R3 is the product of 3 ohm into 5 ohm divided by the sum. On calculation we get 5 by 4 ohm. Let us redraw the given network with the converted star portion that we obtained by transforming the delta portion. Here it is. Look at the terminal points. We cannot change them, and we haven't. This is A and this is B. Call this point O that we derived through the delta to star transformation, where the star resistances met. The resistance between A and C is 1 ohm and resistance between A and D is 2 ohm. Now the star resistances, that between O and D is R3 equal to 5 by 4 ohm. Resistance between O and B is R2, that is 5 by 3 ohm, and resistance between O and C is R1, that is 1 ohm. Let us redraw it to give it a simpler look. This is terminal A and this is B. In the branch ACO, we have two resistances, 1 ohm between AC and 1 ohm between CO. They are in series. So this resistance is a series combination of 1 ohm and 1 ohm. So this is 2 ohm. Again, in this branch ADO, we have two resistances, 2 ohm between AD and 5 by 4 ohm between DO. They are in series. So this resistance is a series combination of 2 ohm and 5 by 4 ohm. So this is 13 by 4 ohm. This is the resistance between OB. It is 5 by 3 ohm. Simplify it further. This is the A point and this is the B point. Obviously 2 ohm and 13 by 4 ohm are in parallel. So this resistance is a parallel combination of them. It turns out to be 26 by 21 ohm, and this is 5 by 3 ohm as before. We are on the verge of getting the final result. the series combination of the resistances 26 by 21 ohm and 5 by 3 ohm is 61 by 21, which is 2.904 ohm. This is the equivalent resistance between the terminals A and B. Call it RAB. Is this answer that we got correct? Let us check it, rederive it. Now applying delta to star transformation to the other delta network that we find in the loop ACD of the given network. Build the star network within the delta ACD. This resistance is R1, this is R2, and this one is R3. Apply conversion formula to move over from delta resistances 1 ohm, 2 ohm, 3 ohm to the star network resistances. So R1 is, R2 is, and R3 is of value. Let us redraw the network with the converted star portion, and here it is. Put the resistances, and this reduces to, here half ohm between OC and 4 ohm between BC are in series, while 1 ohm between OD and 5 ohm between BD are in series. Again 9 by 2 ohm and 6 ohm are in parallel, and so we can simplify the network further. This leads to the equivalent resistance 2.904 ohm, denoted by RAB. We are now doubly assured that we are doing things right, as we have got this answer earlier too. We present two more questions for practice. The questions are: convert to star network the following delta networks. The answer: consider the first delta network, build the corresponding star network, and use the formula to get. Consider the second delta network, build the corresponding star network, and use the formula to get. The next question: convert to delta network the following star networks. The answer: consider the first star network, build the corresponding delta network, and use the formula to get. Consider the second star network, build the corresponding delta network, and use the formula to get. Having done the calculations of conversion from star to delta as well as from delta to star networks, let us put the questions in multiple choice types as follows. Question: which star network is equivalent to the delta network? The options are And this is the correct option we got. Next question. Which delta network is equivalent to the star network? The options are and this is the correct option that we got. Next question. What is the equivalent resistance between A and B of the network? The options are, and this is the correct option that we got. Next question. Construct the star delta network between points PQR. Identify the correct option. The options are these are the correct options. Next question. Consider the networks and match them. Let us label them as A, B, 1 and 2. The options are, and the correct option is